Alright, this is a video explaining how to work out problem number 3 from the moles to mass stoichiometry practice assignment. So, for this and the next two questions after this, we're going to be using this balance equation at the top. So we see that we've got 2 hexanes, reacts with 17 oxygens to produce 12 carbon dioxides and 10 waters. So, we're going to start by asking these questions, breaking down the question to see what we're actually trying to solve with this problem. And it says, if I do this reaction with 3.5 moles of hexane, how many grams of carbon dioxide will be formed? So what do we know? We look for the numbers, and we've got 3.5 moles of hexane, C6H10. What do we want to know? And for that, we look for the question word, and we see the question phrase here is how many grams of carbon dioxide? So we want to know how many grams of carbon dioxide. That's what we want to know. Now, we're going, for these problems, we're going to take this first question, we're going to assign this substance to the right side of our graphic organizer, and this substance to the left side of the graphic organizer. So on this side we've got hexane, on the left side we've got carbon dioxide. So we're starting off with 3.5 moles of hexane. So we're starting off with moles of hexane. And we're trying to get to grams of carbon dioxide. So we're trying to get to the mass of carbon dioxide. So we see to get from moles of hexane down to grams of carbon dioxide, we need to cross two arrows. One arrow here, one arrow there. That means we need two conversion factors. So that's going to help us set up our problem. When we set up our problem, we're going to take what we know and use that as our starting value. So we know we have 3.5 moles of hexane. And we know we need two conversion factors because we crossed two arrows in our graphical organizer off on the left. So, our first arrow takes us from moles of hexane over to moles of carbon dioxide. So we're going to put moles of hexane on the bottom and moles of carbon dioxide on top. Now we know it's a moles to mole conversion, so that means it needs a mole ratio. And to find the numbers that go in a mole ratio, we look at our balanced chemical equation. So the coefficient next to hexane, C6H10, is 2. The coefficient next to carbon dioxide, CO2, is 12. So 12 goes on top, 2 goes on the bottom. Our next conversion takes us from moles of carbon dioxide to mass of carbon dioxide. So we put what we're going away from on the bottom, moles of carbon dioxide, and what we're going to on top, grams of carbon dioxide. That way, moles of carbon dioxide cancel out with moles of carbon dioxide. We're left with grams of carbon dioxide, and that's what we were looking for. Now, anytime you go from moles to mass, we need to find the molar mass. To find the molar mass, you actually need to look at the periodic table. So, the molar mass for carbon dioxide, it's CO2. We need 1 carbon and 2 oxygens. 1 carbon is 12.01. 2 oxygens is 2 times 16. 1 times 12.01 is 12.01. 2 times 16 is 32. There we go. When you add them together, you get 44.01. So that's the number that's going to go with grams of carbon dioxide. So 44.01 goes on top, 1 goes with moles on the bottom. Now let's see what cancels out. Moles of hexane cancels out with moles of hexane. Moles of carbon dioxide cancels out with moles of carbon dioxide, and I think that's all that actually cancels out here. So let's see if we can combine all this into one big fraction and work it from there. So we start off with 3.5. Moles of hexane canceled out, so that we're going to then multiply by, the next thing is 12. And after that, moles of carbon dioxide canceled out, so the thing after that is multiplying by 44.01 grams of carbon dioxide. In the denominator, we've got 2. That canceled out. Multiplying by 1 is still itself, so it doesn't matter. And that canceled out, so the only thing in the bottom is 2. So if we look here at this fraction now, all you have to do is plug this part into the calculator. 3.5 times 12 times 44.01 divided by 2. So I'll go over here and do that real fast. 3.5 times 12 times 44.01 divided by 2. That doesn't look right. It's probably right. Yeah. It is 924.21 grams of carbon dioxide. Now the last step for all of these is to look and see if we have the correct number of significant figures. We see we only have 2 significant figures up here, so we should have 2 significant figures in our answer. So I go down here, this is our first sig fig, here's our second sig fig. Well, that means we need to round to this second place, and that is the tens place. So we need to round 924.21 to the nearest 10. And the nearest 10 for 924 is 920. There's no decimal here, so that 0 is not significant. It's just a placeholder keeping that 2 in the tens place. We only have 2 sig figs, the 9 and the 2, so that 920 grams of carbon dioxide is your answer.